when there are very large numbers of electric charges in every small region, or the large amount of charge is continuously distributed in a small region, it is very convenient to consider the continuous distribution of electric charge instead of taking effect of each individual charge. To illustrate this fact, let us consider the continuous charge distribution on any line, linear charge distribution, as shown in figure. Such charge distribution may not be uniform. Assume that this line is divided into very large number of line segments, vector dl dash. The position vector of one such segment, vector dl dash, shown in the figure, vector r dash. Suppose the charge per unit length in this line segment is lambda of vector r dash. Lambda is the linear charge density and it may depend on vector r dash. The microscopic charge of the amount lambda of vector r dash into modulus of vector dl dash is contained in such line segment vector dl dash. The force exerted by this microscopic charge with the position vector r on the electric charge Q is vector df is equal to K into Q lambda of vector r dash into modulus of vector dl dash upon modulus of vector r minus vector r dash cube into vector r minus vector r dash. Thus, the total force acting on the charge Q can be calculated with the help of equation by taking the summation of terms like vector df on the entire line corresponding to different line segments like vector dl dash. Thus, we can write it in the form of an integral. Total force vector F is equal to KQ integral of lambda of vector r dash into modulus of dl dash upon modulus of vector r minus vector r dash cube into vector r minus vector r dash. If the charge is continuously distributed on some surface, as shown in figure, we can take the microscopic surface elements vector ds dash and find the surface charge density sigma of vector r dash, that is the charge per unit surface, and then we can calculate the force exerted by the charge sigma of vector r dash into vector ds dash contained in each surface element and calculate the total force by taking the integral over the entire surface . Therefore, vector F is equal to kq into integral s sigma of vector r dash into modulus of vector ds dash upon modulus of vector r minus vector r dash cube into vector r minus vector r dash. Similarly, if we consider the continuous charge distribution on any volume, your rho of vector r dash is equal to the charge density in the volume element with a position vector, vector r dash. dV is equal to the volume of the volume element with position vector, vector r dash. We have vector F is equal to kq integral V rho of vector r dash into modulus of vector dV upon vector r minus vector r dash cube into vector r minus vector r dash. In general, if any electric system is composed of 1. Discontinuous electric charge, 2.